Welcome to my third year project. My name is Daniel O'Sullivan and I have developed a wireless proximity defense system. It consists of a main console, which is here, and I have three sensors, which will be independent of the console, and they can be placed in anywhere up to 250 meters in an open area and 75 meters in a built-up area. For the main console itself, it consists of an 8052, which is a ATML microcontroller, the LCD screen with all the switches, switch here to turn on the system. So it's connected with a 9-volt battery through a 5-volt regulator. I'll switch it on and you can see the screen comes on. All the switches I'll explain to you now. We have four switches here, and they are for when a sensor is activated. Example, sensor 1. If I want an alarm to be sirened, an audible alarm, I can push that in. That means that sensor 1 now will siren. If I don't want it, I push it in. Either way, I'll still have a display that zone 1 here has been activated. I have my contrast button, or my backlight on off. I have a learn button for the decoders, a latched button for the input of the decoders. I have a contrast button here, which turns the contrast on and off. I have a receiver here, and I have my decoder here. Also, each sensor can be visually seen with LEDs here, which represent the 4 zones. So the first thing I'm going to do is I'm going to put a battery onto my third sensor here, so I have power. Yes. So that's gone. I have sensor number 2 powered by a PSU, and you can see here there's 5 volts in the circuit. It's 9 volts and it's regulated down to 5 volts. And the second sensor number 1 I have here powered with a PSU here, which is 8.6 volts, and that's also regulated down to 5 volts here. My third sensor here has a 9-volt battery on also. The only reason I'm using 2 PSUs is so I can demonstrate the low battery. On the spectrum analyzer as well, I can show different things. So the first thing I'm going to do is I'm going to show when sensor 1 over here is triggered. So when I push my hand, or pass my hand past here, I can see that the LED here comes on, off, and on again. The same happens with each individual sensor. So for example, here I have sensor 3 here, and you can see on the LCD I'm going to put my hand past it, and on the screen comes the symbol, and it's off. And I'll put my hand past it again, and it's off. So every time a sensor is passed, it's displayed on the screen here that which zone or which sensor has been activated. Sensor 3. For the alarm button here, if I want the alarm to go off when sensor 3 is going off, I can simply push the alarm button. So now when a zone is activated, or zone 3, I get an alarm. So I could have zone 3 as a buzzer, and I can have zone 2 without the buzzer. Zone 3 with a buzzer. Here again. Right, so that's the zones demonstrated. Next thing I'm going to demonstrate is the low battery, and I'm going to use sensor 1 and 2. What I'm going to do is I'm going to regulate the voltage over here, that it drops here to 3.8 volts, 3.3 initially, but I figured out that 3.8 really triggers off the low battery. So as I bring down the voltage slowly, It's triggering on my over here. That's zone 1, which is sensor 1, has a low battery. So when the battery is low enough, that sensor is going to keep transmitting over and over again that an alarm saying that, oh, zone 1 needs a new battery. So if I go out to zone 1 and I put a new battery in it, that brings it back up to 5 volts. We can see here, now the battery is gone. Same with zone 2, I'll adjust zone 2's battery level here with the voltmeter, and you'll see it coming on here. So we're at 5 volts. We're now dropping down to 3.9 volts, 3.6. You can see there now that that's a low battery. That's going to keep transmitting over and over again that it's a low battery. So if I come along and put a new battery into it then, and I'm bringing up the voltage now for a new battery. Now the new battery's in it, and it's back up to 5 volts. There's no low battery anymore. Also, if a sensor goes off, these LEDs can display which sensor's gone off. That's both sensors there at once. I'll display sensor 1. Sensor 1 goes off. That's the sensor 1 LED here. And sensor 2. Right, okay, I have 2 sensors pointing at each other. Let me shift one away. There. So sensor 2 up here, as I pass my hand in front of it, we can see it comes on. And if I go over to sensor 1, you can see it go off there as well. Problems with the project was that on the spectrum analyzer we can see that there's no frequency at the moment. Initially that wasn't the case, as there was constant transmission. So if I show you here, this is sensor 3. Initially there was a constant transmission, and that's because this pin here was always high, or always had a voltage on it. So if I plug that in there, right, so now we can see that there's no, I have to activate it there. You can see here, zone 3, no transmission, no alarm. But look at the spectrum analyzer, the frequency is taken up. I come back down here, no alarm. Now I put my hand in front of it. Spectrum analyzer goes up a small bit, dBs, but it comes back down again. Activated, not activated. So what I did was I used a NOT gate for my sensor. Off my sensor, it goes into the NOT gate, and through a series of 2 inverters, I brought the output to the base of a transistor, and therefore that will turn on a transistor. So now I can put this into the emitter of the transistor here, like that. Now when there's transmission, the NOT gate will always hold through the sensor, because the sensor is 0. This part of the circuit, at the base of the transistor, will be 0, so it's not turned on. So when the sensor goes to 1, through the NOT gate, the base of the transistor goes to it biases the transistor, which turns on the transistor. Therefore, a transistor which is fed with 9 volts can feed current to the transmitter. So now that there's no frequency there, you see in the spectrum analyzer, when I pass my hand in front of the sensor, it jumps up. So now all transmitters can transmit without there being a blocking of that signal. Thanks very much.